Okay, your lesson is 11.3. This is the last lesson on conic section, so we have parabolas, ellipses, and then we have hyperbolas. You get hyperbolas by cutting, let's say we had two cones. Let's see how beautiful I can draw this. Ooh, that's not too bad. There we go. Here we go. Here and here. Ooh, this just got even worse. So we got two cones that are touching at their points. If you cut those cones straight down, so we're going to cut them straight like this, you would get two sections. So pretend like this is a plane that's cutting through that cone. We will get two sections of our graph. We'll have one on the top and on the bottom, one on the bottom, or if it's side to side, one on either side. So that's how you get a hyperbola. I'll let you know what the equations are, how it looks on the graph, and how we can find our foci. So the first thing I'm going to do is just draw the vertical or the horizontal parabola, the vertical parabola, and then how you get either one of those equations and how you can graph it from that. Okay? Alright, so we'll start out with a parabola that is going side to side. So we've got, not parabola, hyperbola, sorry. We have 2 points where we're going to go, and it's going to look like this. It's going to look like this. And your foci for your hyperbola are inside of your curves. Okay? So these are our foci. And this is the hyperbola. I call them side to side, but these are the ones that are the horizontal hyperbola. So we have both of those parts. A vertical hyperbola looks like this. It's the same except that it is up and down instead of side to side. These points here, here, with our foci inside of our graphs, inside of our curves. So that's what the picture looks like that we're going to draw. And now I'll write down what the equations are to get us to these things, and then I'll show you how to sketch them. I'm going to cut out a lot of stuff in this one to maybe make this video a little bit shorter. I try every day. It doesn't always work. So if you're going from side to side, your x squared is going to be your first thing you start with. So we'll have x squared over a squared minus y squared over b squared, and that's going to equal 1. So the only difference between the hyperbola equation and the ellipse equation is that you have a minus sign instead of a plus sign. So if your hyperbola is side to side, your x squared is going to start off your equation. Okay? And you probably guessed that for it to be up and down, the y squared is going to start the equation. So y squared over a squared minus x squared over b squared, and that's going to equal 1. Alright, and to figure out our foci, or what our c value is, the distance from the center to the foci, it's also a reverse of the ellipse. Ellipse plus c squared is a squared minus b squared. This one, to find our foci, to find our c squared is a squared plus b squared, which is just the Pythagorean theorem. And if you want to know why that's the case, you can ask me, and I'll let you know. I'm just not going to put it in here because it'll take too long for me to draw all that. So, okay. So those are our equations, and now we're going to figure out how do we use these equations to make the graphs that we have here. So now we'll do 2 examples, and we'll do one vertical, one horizontal, one vertical, and a transformation, and that should be it for today. Okay. Alright, so let's say I had x squared over 16 minus y squared over 36, and this is going to equal 1. So the first thing I want to do is see, did I start with the x or did I start with the y? I started with the x, so I know it's going to be a side-to-side hyperbola, but I have to figure out how I get the shape. So the numbers on the bottom are important, like they were for the ellipse. 16 is 4 squared. That's going to be important in my x direction. And 36 is 6 squared. So this is how we get our shape. So you draw your graph, and you start out exactly like you would have had it been an ellipse. So we put all the points on here just like it's an ellipse. So I'm going 4 in the x direction and 6 in the y direction. Okay? So I need to know that these points are important. The 4, and then this, and then that one. Okay, so I got my 4s underneath the x, 6 underneath the y. And here you are going to draw a rectangle that goes through all of these points. It's going to let us know what shape our hyperbola is going to be. It's going to give us some guidance for the asymptote. So we draw a second. So here we go. Draw a rectangle that, oops, I missed that point. That would be better. That goes through these points. Okay. And now I draw an asymptote through the diagonals. I'm going to go straight through my diagonals. Okay? So you use those numbers to draw your rectangle and then your asymptotes. And then you look and remember, was it an x or was it a y? So this was an x hyperbola, so it's going to be side to side. So your vertices of these are going to be on these points. Since it's a side to side, it's the ones that are on the x-axis. And then you use your asymptotes to guide you for how steep your hyperbola needs to be. So I'm going to go along, hit that, and then come back through close to the other asymptote. And do it for the same on the other side. There, and then there we go. Okay? So now we'll do a vertical one, and then a transformation. Oh, we haven't found our foci. Sorry about that. So let's do that next. We can put them on our graph. So c squared was, what was it, a squared plus b squared, which in this case is 4 squared plus 6 squared. 16 plus 36 is 52. And the square root of 52, does 52 have a perfect square in it? Yeah, it does. So that's 4 times 13. So C is 2 root 13. Okay. So let's see. We're going to write that down. So that is the square root of 52 away from the center. The square root of 52 is between 7 and 8. So we need to go 1, 2, 3, 4, 5. Let me play some more marks. 5, 6, 7, 8. 5, 6, 7, 8. And I'll put my foci between 7 and 8. And I'll write those ordered pairs down. So my foci would be 2 root 13, 0, and negative 2 root 13, 0. And if you're asked for the vertices, we have those as well. We can write them down too. So our vertices are negative 4, 0, and 4, 0. Okay? You might be asked for the length of the different axes. The one that does not actually have the graph on it, so in this case the y one, it's called the conjugate axis. So if somebody says what's the length of the conjugate axis, in this case it would be 12. So conjugate axis means the one that does not have the vertices on it. You'll need that when you're writing your equations. Okay. Alright, now we'll do a vertical one. So for it to be vertical, we know it has to start with a y squared. So y squared comes first. That's the one that will be positive. The x squared part will be negative. Let's do y squared over 10 minus x squared over 25. And then we'll say that equals 1. Okay? Alright, so on this one it's a little bit different because 10's not a perfect square, so I can't just write, oh, that is something squared. So instead, I'm going to have to say that we're going to do the square root of 10. That's square root of 10 squared. And then over here, 25 we know is 5 squared. So when I'm going in the x direction, I'll be going the square root of 10, y direction, sorry. Going the square root of 10 away from our center. So if it's not a perfect square, you can do the decimal value for that if you like that better when you're graphing. That's fine with me, I don't care. So 5, 1, 2, 3, 4, 5, and the square root of 10 is between 3 and 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so I'm going to put my points on there. Say 3 point a little bit, 3 point a little bit, 5, 5. Draw your rectangle. So if you could do your ellipse graphing yesterday, you should be able to do this hyperbola graphing. It's the same general basic stuff. Okay, so there we go. Now we'll draw our asymptote. It goes through the diagonals as our guide. Okay, and then we remind ourselves that y squared started first. So we are going to use the y's as our vertices, and we'll draw our hyperbola up and down. Okay, so if I was going to write my vertices down, my vertices will be 0, root 10, and 0, negative root 10. And now I'll find my foci. C squared is a squared plus b squared, which is 10 plus 25, that's 35. So C is the square root of 35, and that cannot be broken down anymore. So the square root of 35 is between 5 and 6. 1, 2, 3, 4, 5, 6, 5, 6. It's closer to 6 though. It's almost 6. 1, 2, 3, 4, 5. Almost 6. 1, 2, 3, 4, 5. Almost 6. So then the ordered pairs for that would be 0, root 35, and 0, negative root 35. Okay. Alright, our very last one is transformation. So this is the same thing as before. It'll be with parentheses, with the x's and the y's, and you just shift the opposite way. At this point, I think y'all are pretty good at that, but I do want to make sure everybody's okay with the ordered pairs. That's where I see the most mistakes when we're doing hyperbolas. Let's go x minus 2 squared over 4 minus y plus 3 squared over 16 equals 1. So we know it's x is going to come first, so it's going to look like this, side to side. 4 is 2 squared, 16 is 4 squared, so we'll go that much once we figure out what our center is. And then x minus 2, when the x, it's left and right, so that's going to the right 2. And with the y, that's up and down. We always do opposite for these, so this is down 3. So I think that's all that we need to know at this point. So we're going right 2, down 3, and that's where we start, and then we do everything else off of that ordered pair. Okay. So right 2, down 3, at your point, and then we go x direction, 2 left and 2 right. So 1, 2, 1, 2. Y direction, 4 up and 4 down. 1, 2, 3, 4. 1, 2, and one more point down here. 1, 2, 3, 4. We draw our rectangle. Okay. Make our asymptotes. So it's going to be beautiful, I can tell. Alright. Then we check out and remember, was this X or Y? So X is, started with an X up here. Yep. So it's going to be side to side. So our vertices are on the ones on the side to side. And we sketch our hyperbola this way. Okay. And now we'll write down what our vertices are and our foci. So our vertices are the points on our hyperbola here. So this one is 4, -3. And the second one is going to be 0, -3. Okay. Now for our foci, c squared is a squared plus b squared, which is 4 plus 16. That's 20, so c is the square root of 20, and that is 4 and 5, so 2√5. Okay, so we are going the square root of 20 to the left and to the right of our center point. So the square root of 20 is between 4 and 5. We're going 1, 2, 3, 4, and a little. 1, 2, 3, 4, and a little bit. So those ordered pairs, let's see what those ordered pairs would be. So this first one, where were we to start in the center? We were at 2, and we went right square root of 20, or 2√5. So our x value is now going to be 2 plus 2√5 at this point. And the y value is still -3. We didn't go up and down at all. And over on the left foci, we were at 2, and we went to the left 2√5. So when you go to the left, that's a minus. So 2 minus 2√5. The -3 is still the y value for that. Okay? You will have some where you have to write the equation, and it gives you the vertices and also gives you the conjugate, the size of the conjugate axis, or that distance. So remember, the conjugate axis is the opposite one, the one that does not have the vertices in it. So if you see that, that's what that means. Okay. Oh, I did want to show you just real quick a pretty graph, one that I didn't draw myself, but it's in the Desmos graphing calculator website that you can use. It doesn't matter. So I just typed in the first one that we did, the x squared over 16 minus y squared over 36 equals 1. And it graphed that beautifully for me. You can see kind of where the box would have been and where the asymptotes would have been as well. So also put that in, then made a vertical one as well to see what that would look like for that part. Okay. On your test that you have in a couple days, you will have the opportunity to use this graphing calculator to, you're going to draw a picture. I'm going to tell you a certain amount of ellipses and hyperbolas and parabolas I want you to do, and you'll just make them in this. But I'll make a whole video on how to type those in and how to save it and stuff with your study guide, so you know exactly what to do. But that will be part of your test coming up. So you'll have something on the CudaWorks and then also a Desmos graphing thing. There's both of them together. You can zoom in and out if you want to. Looks just like an X if you zoom in. Alright, y'all have a good day. Nope, it's 19 minutes. I tried and it's exactly the same length. Oh well. I won't see you later, actually. I was going to say see you later, but that's sad. If you have any questions, you can ask me, and I'll talk to you soon. Bye.